So Hamza, write the heading. Questions on calculating. Questions on calculating the equivalent resistance questions on calculating equivalent resistance. So we will have different kinds of combination of resistances, and we will calculate the equivalent resistance of these circuits. So type 1 is like in these kinds of series, in these kinds of combination, you will decide series and parallel combination via geometry of wiring. Why the geometry? And just I am revising this again. I have told you earlier, if the resistances are connected like this, means if you have this single wire and you have connected one resistance here, if you have this a single wire like uh, this is a single wire you have, and you have connected one resistance here, one resistance here, and one resistance here. Means on a single wire, when you have connected the resistance, that combination is known as the series combination. This is resistance. If this is R1, this is R2, if this is R3, and I have told you, if the wire is same, then the current is same. If the wire is same, then the current is same. So this combination is series. Earlier we have discussed, and I have also discussed, if two resistances are connected or three resistances are connected end to end, means one end of this resistance is connected here, another end of this resistance is connected here, and this is the connection. Earlier you have connected this also with battery. So this kind of combination is called parallel combination. And I have also told you that across this R1, across this R2, across this R3, the potential, not the potential, means potential difference V or the voltage is same as that of battery. But here across each resistance, the current is same. This we have discussed earlier. So in this class, we will not discuss this. We have discussed this earlier. We will solve the question only. The first question is, actually this is a question like this. This is the wiring in the form of square, and one resistance is like this. One resistance is connected on this wire. One resistance is connected on this wire. One resistance is connected on this wire, and there is another wire here like this, and another resistance is connected like this, and this is a point A, this is a point B, this is a point C, and this is a point D. And all resistances have the value R. All resistances have the value R. This is given, and we have to calculate. Number one, equivalent resistance means R equivalent resistance between A and C, between point A and C. A and C. Second question is, we have to calculate the R equivalent between point A and D. Between point A and C, first we have to calculate the equivalent resistance, and after we will calculate the equivalent resistance between the point A and D. So I am solving the first part of the question. So there is a procedure to solve these kinds of questions. There is a procedure. So we have to calculate the equivalent resistance between point A and C. Now what you will do, this is answer first. If you want to calculate the equivalent resistance between point A and C, just imagine there is a battery. Just imagine there is a battery or cell in between these 2 points. Just imagine. Okay. Now focus only on A point and B point. Now there is no B and there is no point D. Means there are the points, but now we will neglect these points. Means this ABC is a single wire. ABC becomes the single wire, and this ADC becomes the single wire. Okay, Hamza? This whole wire will have same current, and this whole wire will have the same current, irrespective of the amount of current. So you can say, if I am supposing this as resistance 1, you can take this resistance as 1, this resistance as 2, this resistance as 3, this resistance as 4, this resistance as 5. So you will say resistance 4 and 5 are connected in series. So you can calculate the resultant of resistance 4 and 5, R plus R. This will become 2R, and accordingly resistance 1 and 2 is connected in series. Also 1 and 2 is connected in series. Why I am saying 1 and 2 is in series, because this now becomes the single wire. This is a single wire now. Okay, branching is from the point C. See, there are 4 branches. One branch is there, but this wire is single wire, and resistances on the single wire are in series. So you can also find R12. So you will write R1 plus R2. Why I am writing R1 plus R2? Because this is a series combination. In series combination, the equivalent resistance, that is R12, is calculated like this, R1 plus R2. So you can calculate R plus R. This also becomes 2R. And now what you will do? Now you will modify this circuit. Now you will modify this circuit. You will solve the question step by step. Please, Hamza, I will give you the time of writing. I will give you the time of writing. It now. This is important here to concentrate, because these questions are very, very important for your exam point of view. Okay. So Hamza, now the equivalent of this and this is 2R. So what I will do, I will just remove this R and connect it via single resistance. Connected via single resistance. So actually my laptop is little bit slow. That is why I'm getting some problem. So I am just removing this very, very slow. Okay. Now I am just removing this resistance. Now on this wire, we will have just one resistance. We will have just one resistance. And same is the case here. We will have just one resistance, that is equivalent resistance of 2R. We will have. Very, very. Actually, laptop is not working properly. Okay, but we can manage. So now I am just connecting a single resistance instead of 2 resistances. I am just connecting a single resistance of resistance 2R. Here also I am just connecting a single resistance of resistance 2R. See here, Hamza. Now this 2R here, this resistance ABC, this ABC is resistance 4,5. The equivalent of resistance ABC is 4,5. R45 is 2R. So this is the resistance. This was R45 and this was R12. This was R12 and this is R, means R3 you can say. This is R3. So Hamza, see this 2R, this R and this 2R. Are they connected end to end? Hamza?
Yes.
These resistances are connected end to end. See this. One end of this resistance, another end of this resistance, another end of this resistance. At this end, one end of this resistance, one end of this resistance, one end of this. If the resistances are connected end to end, then you can say resistances are connected in parallel combination. So you can write R45 R3, comma R12 are connected in parallel combination. Are connected in parallel combination, and in the parallel combination, one thing is more, the potential difference across each resistance will be same. So in parallel combination, how we will calculate the equivalent resistance means R1, 2, 3, 4. R1, 2, 3, 4 is the equivalent resistance of the circuit. How we will calculate? We have these three resistances. Hamza, do you know equivalent resistance in parallel?
Yes, sir.
Okay, now tell me what should I write here? See, this is 1 upon R45 plus 1 upon R3 plus 1 upon R12. Okay, R45 is 2R, R45 is 2R, R12 is 2R, and R3 is R. So I am writing here 1 upon 2R plus 1 upon R plus 1 upon 2R. Now Hamza, can you solve this expression? Try this and tell me the answer. Try this on your copy. This expression. I want. Please solve this. Beta completed. Hamza completed.
No, sir.
Are you solving this or not? I
Yes,
am
sir,
just
but I'm not able to understand that. How to like?
how to solve this, na? You are
Yes.
not. Okay, very good. I am just telling. See here now, Hamza. Very carefully, very carefully. This is the thing, na? We have to solve. Hamza,
Yes.
can you solve this 1 upon 4 plus 1 upon 2 plus 1 upon 4? Can you solve this? What is the
Yes.
answer? So first try this, then we will solve this. The answer is hidden here.
Sir, it's one.
It's 1. Okay. So it's 1 now. So how you have solved this? Let's see. You have taken the LCM for, in this way you are solving now.
Okay, sir. 1 minute. I can solve it. 1 minute. Let me try. I can solve that one.
LCM is 4. So this is 1. This is 2. This is 1. Same is the case here.
Yes, sir. Yes, sir. I'm solving. 1 minute.
Okay, no problem. You can take your time.
Sir, answer is 2 by R.
Very good. Very good. Just we will see this.
That's correct or not?
I am solving, just say it. But at least I am happy that you have tried this. So what you will do, you will take the LCM 2R here. If you are taking the LCM 2R means here is 2R, here is 2R, so here will be 1. Here is R, here is 2R, so here will be 2. Here is 2R and here is 2R, here is 1. So you will get 4 divided by 2R and your answer is right. Means you are getting the answer 2 by R. Very good answer. Very good. So now you have 1 divided by R, 1, 2, 3, 4. And this is 2 divided by R. But we have to find R, 1, 2, 3, 4. We have to find this term. So what we will do? We will do cross multiplication.
Yes, and we will
So
get R is equal to
no, we have to find this quantity R1, this. So you will get, this is the reciprocal. Just reciprocate this, not reciprocate, but take the reciprocal of this. What is the meaning of reciprocal? Is 2 by R is written like this. The reciprocal means if you
R
are
by
taking the
2. R by
yeah
2.
R by 2. So take the reciprocal on both sides. You will get 1, 2, 3, 4. Reciprocal of this is this R by 1 means, and this is the reciprocal of the R by 2. So R by 1 can be written as R1, 2, 3, 4, and this can be written as R by 2. See, the answer is R by 2. Answer is R by 2. Very good. So in this way, you can solve these kinds of questions. This question is looking complicated, but this question is not complicated if we solve this question in a planned way, step by step manner. Means we have just completed the first part of the question. Means we have found the equivalent resistance between point A and point C. Now we will calculate the equivalent resistance between point A and D. Now we will calculate the equivalent resistance between point A and D. Second part of the question. So answer second. Now you want to solve the resistance, you want to find the resistance between point A and D. A and D. Just focus on the point A and D. What you will do, just connect the imaginary cell between point, imaginary cell I am saying, between point A and D. Now focus only on point A and D. Neglect point B, C and all these things. And I am representing this resistance as 1, this resistance as 2, this resistance as 3, this resistance as 4, this resistance as 5. Means this is 1, 2, 3, 4, 5. You can name the resistance according to you. Okay. There is no foundation. You can number the resistance. So now Hamza, one thing you can see here, actually you have to observe the circuit again and again. You have to observe the circuit. Now see here, this A, B, C is a single wire. ABC is a single wire, no? Because the current here will be same, because there is no branching in this wire. There are no branches in this wire. There are no branches here. So you can say ABC is a single wire, and I told you that on a single wire the resistances are connected in, Hamza, resistance are connected in Series or parallel in single wire?
Sir, series.
Yeah, series. So you can say resistance 4 and resistance 5 are in series. So can you find resultant of R4 5? Means you will write R plus R. This will become 2R. This will become 2R. So R4 5 we have. Now we will again modify this circuit.
Sir, but we need only for AD, right? Why are we taking 4 and 5?
You are right. You are right, Hamza. But I know that you are right. But actually, there is no other way to solve. We need the resistance between A and D. Total resistance between A and D we need. Okay, you are thinking that this resistance will be the answer,
Yeah.
but no. Between A and D, this also is in between A and D.
Oh, yes, because it's in series. That's why.
Yeah, this is in series. That is the another point. See here, I'm just giving one example. Here is one point A, here is one point B. Okay, and here is wire. Okay, here is wire, and I am saying, suppose here is a country. Here is one country. Here is one country R. Name is R. Here is another country whose name is 2R. And here is another country whose name is 3R. And here is another country whose name is 4R. So Hamza, you are right. You are right. Between A and B, there is a country named R. But this country also is in between A and B. Is it in between A and B or not? This 2R is in between A and B also. This 4R is in between A and B. This 3R is also in between A and B. So in between A and B, there is a resistance R here. In between A and B, there are these resistance also. Getting my points?
Yes, sir.
Very good point, Hamza. Means you have to consider this resistance also. Not consider, but these resistances are also in between A and B. A and B. Means they are connect. If there is no wire here, suppose if I have disconnected this from here, I have disconnected this from here. In this case, you can say, in that case, you can say I have connected here this wire from here. In that case, you can say in between A and B there is only resistance R, but the wiring is there. So we have to take this also. So by the way, I'm just modifying this circuit. So now instead of 4 and 5, we have R4 5, that is 2R. So I am removing this. I am removing this resistance here from here, this from here. You have to follow the same procedure that I am following. Now connect in between A and C only one resistance of 2 ohm. 2 ohm. And this resistance we have named R R45. This resistance was R45. Now Hamza, we have to identify once again. We have to observe the circuit and identify once again which resistances are connected in series and which are in parallel. Now Hamza, see here, see this point and this point A and C, you can see this R is connected with 2R end to end, means you can say resistance 3 and resistance R45 are connected end to end or not. You have to identify this C, na? They are connected, this 2R and this R are connected end to end, na? Means this means that end to end connection means that 3 and resistance R45, that is 2R, are in parallel. One by one we will solve, one by one. We will identify and solve one part of the circuit. Again we will identify and solve the one part of the circuit. This is the only way to solve the circuit. So 3 and R45, what is the value of resistance 3 R and what is the value of R45, that is 2R, means R and 2R are in parallel combination. So we can find the R345. 345 means 1 upon R3 plus 1 upon R45. So can you solve this? 1 by R plus 1 upon 2R. Can you solve this, Hamza? Please try this. This is same as that we have solved in the previous question. So 1 upon R3. Okay. Solve this.
So it will be 3 by 2R.
Yeah, very good. Very good. Take 2R LCM. Here 2, here 1. You will get 3 divided by 2 upon R. And if you want to find this R, 3, 4, 5, means then you will get the reciprocal of this, means 2 by 3R you will get. Now again, we have just calculated the resultant of these two resistance, equivalent resistance of this resistance and this resistance. Now we will again modify the circuit. This is the simplest method. Otherwise, you will get confused in solving. So now I am just removing this resistance and connecting a resistance of 2 by 3 instead of this R and 2R. Now I am just removing this, and I am connecting a single resistance of value 2 by 3R. So here I am connecting a single resistance of, you can just connect this resistance like this, whatever the way you want, because these resistances are on the single wire. Hmm. This is working very, very slowly. One note. I am also getting problem by this. Just connect this, and this resistance we have now 2 by 3R. 2 by 3 into R. And this resistance is known as R345. Now Hamza, tell me this resistance 2 and 345 means this resistance and this resistance are connected in series or parallel. Can you identify this?
Sir, they are connected in series.
Very good, very good. Why in series? Because there is no branching. There is no branching. Means you can say R3, 4, 5. That is 2 by 3R and 2 are connected in series because there are no branches. They are connecting on a single wire like this. Suppose if the wire is like this. Suppose if the wire is like this. The resistances are connected on the wire. Na? So suppose this is the wire. Okay. And I have connected one resistance here. You can imagine, and one resistance here. Now I am folding this wire like this. So if you will fold the wire, this combination will remain same. Combination will not change. Series combination will remain series combination if you will fold the wire. This is the folding of wire. So you can calculate the equivalent, means you can calculate the R 2, 3, 4, 5. So how you will calculate? You will just add this R with this 2 by 3R. Means you will write R2 plus R3, 4, 5. R2 is R and this R3, 4, 5 is 2 by 3R. So take the LCM as 3. Take the LCM as 3 and cross multiply this. This will become 3R. This will become 2R. This will become 5 divided by 3 into R. So R2, 3, 4, 5 is given as 5 by 3R. Means the equivalent of this and this. Now what we will do? We will again modify this circuit. Instead of this and this, I am just connecting a resistance of 5 by 3R. 5 by 3R. I am just connecting. Actually, Hamzada, my system is working very slowly, so that is why both of us are getting problem. So inshallah tomorrow it will be fine. So means day after tomorrow. It is taking too much time for. Now I am just removing this. The response of one node is very, very slow. So just connect one resistance of 5 by 3R here. Just connect a resistance of just 5 by 3R. So now Hamza, see this end and this end. This is end A. Are this is end to end connection of resistance, this resistance and this resistance. So this will be series or parallel?
Sir, this is series.
2 3 4 5. Array, actually I am saying this. See this, na? This is end-to-end connection.
Yes.
This end-to-end connection means parallel connection. See here, na? End-to-end, parallel. Okay. So here also this resistance and this both resistance are connected with one end and with another end. So means this is a parallel combination. One and forward connected end to end. End to end means uh, one end of the resistance is connected with another end of the resistance, and one end of the resistance is connected with another end of the resistance. So this is the parallel combination. So now you can find 1 upon R, 1, 2, 3, 4, 5. You can find this 1 upon R1. This is R1 plus 1 upon R 2, 3, 4, 5. This is R2, 3, 4, 5. Now 1 upon R1 is 1 upon R1 is R, and this is 5 by 3R. Now we can solve this. Okay. Okay, no, not 5 by 3R. We will take the reciprocal of this. This is 5R by 3, na? Sorry. This is 5R by 3, na? So we will write 1 upon 5R by 3. So you will get 1 by R plus 3 divided by 5R. Now take the LCM as 5R of this. Take the LCM 5R here. So if you will take the LCM 5R, then here you will get 5 and here you will get 3. So you will get 8 divided by 5, 8R by 5, and the answer will be 5 by 8R. Answer will be 5 by 8R. So R 1, 2, 3, 4, 5 means 8R divided by 5, and this is equal to, what is this? This is RAD, resistance between point A and D. This is 8R divided by 5. So this is your answer. This is your answer. I have given the numbers. I have given the numbers to resistance just for the easiness in the solving. So please note it down, Hamza. Take the screenshots,
Okay, sir.
or and just give me a minute. Just zoom. I'm just zooming it out. It's fine now. Now you can ask me for scrolling down. Taken the screenshot.
Sir, 1 minute.
Okay.
Done.
Okay. So now take the screenshot of this. Step by step you have to solve, step by step.
Done.
Very good. Now take the screenshot of this.
Done.
Fine. Now take this.
Done.
Okay, good. Now So this is the second part of the question and take the screenshot. Otherwise, you will get confused.
Done.
Okay, now take this. And in your laptop, make a folder physics, current electricity, chapter current electricity, and topic this and this.
Yes, sir. I made a
Yeah,
Zoom
very good.
group in which all my notes are there in Zoom
Hmm,
itself.
very good, very good. In the order, you have to follow the things.
Yes, yes.
Otherwise, you will get confused. If
Hold
only
on.
one screenshot is there and there, then you will get confused. Okay, this is the final part.
Done.
Very good. Okay, so this is one of the kind of question you will get in your exam, in your CBSE board exam. You can get. You have to solve this question in this way, step by step. You have to just connect the imaginary battery. Connect the imaginary battery between the resistances. So see on this means this is not looking like a series combination, not looking like a parallel combination. This is just a complex circuit, you can say. But if we follow the steps, then see we have got the answer. And this R, this is RAC. This is RAC. That is R by 2. RAC means between A and C. Between A and C. And when you will practice this question, you will get, you can solve faster than me also. Now there is one more question, and that question is very good question. Just wait, this is not working properly. I'm sorry for that. Actually, I want to make a circle. It's not working. What is happening? See, now it is. Okay, no problem. Now it's fine. Now it's fine. So the wiring, this is a circular wire, this is a circular wire we have. This is the question that we will solve. This is one of the good question, I will say. This is one of the good question. So this is a circular wire. So on this circular wire, resistances are connected. Here another wire is connected like this. Okay, another wire is connected like this. See Hamza, there was a circular wire and another wire is connected like this with a resistance of 10 ohm, and this also a resistance of 10 ohm. Here are resistance. Here is, this is a resistance. Na? Resistance is represented like this. A 2 ohm resistance is connected here, and a 5 ohm resistance is connected here, and we have to find the resistance between A and B. Resistance between this point A and this point B. I'm just so this is the question. We have to find the resistance between point A and B. So now look at the circuit very carefully. Look at this circuit very carefully. What we will do, just copying this. Sorry. This is getting very much. What should I do? Just wait for 1 minute. See this? What is happening? How will I copy this? The response is very, very slow. Yeah. Now it's okay. Now it's fine. Okay, now on the C. It is taking too much time. Sorry for that. Now, see, Hamza, this is a single wire, no? This, 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 and this. This is a single wire.
Yes,
What
sir.
is why this is a single wire? Because actually, initially, this wire is like this, but they are connected this wire with a circular wire like this. Means, like this, they have connected. You can see this. This is the wire earlier. Okay. This was the wire earlier. So this was the wire. This was the wire earlier, and they have connected that wire like this. Means like this they have connected. This one end is this and one end is this. They have connected. So the wire is same, current is same, means this 10 ohm and 10 ohm are connected in series or parallel. Tell Hamza.
Um, so this is parallel.
Why this is parallel? This is series, because I am saying the wire is same. If the wire is same, the current is same. The current is same means the series combination.
Yes.
Hmm. This wire is same wire. I have told you, like this. They have just folded this wire like this. Okay, no problem. So I am just writing here 2 and 3. Resistance 2 and 3 are in series. Can we find R23 in series combination? R2 plus R3. What is R2? That is 10. This is also 10. This will become 20. R23 is 20. Now again modify this diagram, modify this circuit. We have connected the equivalent resistance of this and this. Now we will connect a resistance of 20 ohm instead of two 10 ohm resistances. So what I am going to do here, just removing this. Instead of this, I am just connecting a single 20 ohm equivalent resistance. A 20 ohm equivalent resistance means you can ohm. Now see this and this. This resistance is R12, R23. This resistance is R23. And see here, this R23 and 1 means 1 and R23 are connected end to end. End to end connection is there. End to end connection in between 20 ohm and 2 ohm. So you can write this is a parallel combination. This is a parallel combination. So for parallel combination, if you want to find the equivalent resistance, that is 1 upon R231. R123 you can say. So you will write 1 upon R1 plus 1 upon R23. This will become 1 upon R1. This is R1. 1 means R1. 1 upon 2 plus 1 upon 20. So 1 upon 2 plus 1 upon 20. 20 is the LCM. 2 tens are 20. This will become 1. This will become 11 divided by 20. 11 divided by 20. Okay, Hamza. So we have 1 upon R123. So we can calculate R123 from here, reciprocal of this 20 by 11. We will get 20 by 11 ohm. So we have just calculated this equivalent of this. And instead of these two resistances, we will connect a resistance of 20 by 11 ohm. So again, I am just modifying this circuit. So instead of this 20 ohm and 2 ohm, we will use a 20 by 11 ohm resistance only. a resistance of this was the connection. Now we have a single resistance of 20 by 11 ohm and we have a resistance of 5 ohm. Now Hamza, please tell me, this 20 by 11 ohm and 5 ohm are in series or parallel?
Sir, they are in series.
Very good, because the wire is same. They are connecting on the same wire. So you can calculate the equivalent resistance na, between this 4 and this is, what is this? This is 1, 2, 3. This is R1, 2, 3. So this is a series combination. So you can calculate R1, 2, 3, 4. This is R1, 2, 3 plus R4. This is R4. R1, 2, 3 is 20 by 11. R4 is 5. And take the LCM as 11. You will get 20 plus 11 5s are 55. You will get 75 divided by 11 ohm is as the answer. So total R123 is the resistance between point A and B, and that is equal to 75 divided by 11 ohm. Ohm is the unit of resistance. So this is the final answer. So in this way you can solve the question step by step manner, and when you will do the practice, then you can solve the questions with a proper speed. Now please note down the question, and the question was find resistance between, this is between A and B. Okay, Hamza, note it down. Just take the screenshot and I am scrolling it down.
Sir, done.
Done. Okay, just wait. I'm just zooming it out. Okay, take the screenshot of this also.
Done.
Now take the screenshot of this.
Done.
Take this also, because this is the answer.
Done.
Fine. Now take this.
Done.
Okay. Now finally take this.
Done.
So we have solved two questions. Very, very good questions we have solved. Now there is one more type of question, and very interesting question we will have. Very, very interesting question. Type second. Type second question we will have. This question is based on the potential divider method. Potential divider method. And I have told you resistances having same potential difference are in parallel. Are in parallel combination. So if I am giving you a question, I am saying one resistance is connected like this, one resistance is connected like this, one resistance is connected like this, and a wire is connecting with this, and a wire is connecting with this. And B have to find the resistance between point A and B. Find, we have to solve this question, and this resistance is given as R, this is R, and this is R. We have to find resistance between point A and B. We have to find this. So this is very simple question. Actually, this is a parallel combination, but I will prove how this is the parallel combination. How I am saying this is a parallel combination. In parallel combination, remember only one point: the potential difference across each resistance is same. So now let's focus here very carefully. I will use different color right this time. Okay. So I have told you, if in the path, this is point A, so the potential of this point A is VA. Here also the potential is VA. Here also the potential is VA. Here also the potential is VA. Because if you are moving, if there is no resistance in the path, then you can say the potential is same. So at this point also the potential is VA, and here the potential is VB. Here the potential is VB. Here the potential is VB. Here also the potential is VB. Here also the potential is VB. Here also the potential is VB. Now, this is a resistance R. This is a resistance R. This is another resistance R. Suppose this R is as R1. This is R2, and this is R3. R1 is R, R2 is R, and R3 is R. So the potential difference between this R is VA minus VB. Potential difference between R1, that is R, is equal to, what is the potential difference? VA. Here also the potential will be VA, because there is no resistance in the path. VA minus VB. Potential difference between R2, again R2 is R. What is the potential difference between R2? VB minus VA. And VB minus VA and VA minus VB is same. VA minus VB is same, means I am taking just the difference. So potential difference between R3, that is again R3 is R, that is again VA minus VB. So see, across all the resistances, the potential difference is same. Across all three resistances, the potential difference is same. The potential difference is same. So you can say R1, R2 and R3, and both are, R1 is R, R2 is R, and R3 is also R, are connected in parallel. Why they are connecting in parallel? Because the potential difference across each resistance is same. So means this R are connected in parallel. So can I find the 1 upon R equivalent? 1 upon R equivalent will be 1 upon R1. 1 upon R2, 1 upon R3. So this is 1 upon R, 1 upon R plus 1 upon R. This will become 3 by R. Then R equivalent you will get R divided by 3. This is the answer. Okay, note it down. This is another type of question you will get.
Done, sir.
Okay. Take the screenshot of this now.
Yes, sir. Done.
Okay. Take this.
Done.
Okay. Fine. Answer is this RY3.
Done.
Okay, fine. So this is one of the kind of question. This is one of the kind of question. This combination is the parallel combination, but this is not looking like a parallel combination. Okay. Type third. Type third is short circuit. Short circuit. So the meaning of short circuit is if you have a suppose if you have a resistance like this and you have connected this resistance with a wire, single wire, conducting wire. So you can replace this wire as this system as a single wire. Single wire having a current I. If this has a current I, this is the single wire. So Hamza, let's focus here. Why I am writing this thing as this. See here. Hamza.
Yes, sir.
Okay, let's focus here. Why I am writing this as this? Because this is the current and this all the current will go through this path. All the current will go through this path. So there is no current here. So we know that V is equal to IR. So R is equal to V divided by I. So that is not valid here. So all the current will go, and without the current, there is no existence of resistance in the circuit solving. Suppose if you are having two paths, there is one path this and there is one path this. But in this path, there are some problems, there are some hindrance. So you will follow this path. So like this, the current follow this path, not this path. So current across this resistance is 0. So that is why this resistance will vanish in the circuit. Heating left. Oh, shit. Hamza, please note it down, and I am just leaving the class here, okay? Because there is some problem in my laptop. My laptop is heating. Hamza, are you getting?
So can you say again?
I'm saying that there is some problem in my laptop, and I am just leaving this class here, okay?
Okay.
So we will discuss the rest thing in the next class, okay?
Okay, sir. No problem.
Okay, and uh, just in the next class, make sure that revise your note, okay? Okay, Hamza?
Okay, sir. No problem. Assalamu alaikum.
Okay. Walaikum